Hi guys, my name is Vasile and I want to make a short presentation of VPC, Visual Pin Configurator. In the previous video where there is no sound, I mentioned two reasons, one being technical difficulties regarding sound recording, and the second, my poor spoken English. So now you can hear that constant sound, tick tack 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 tick, something like that, and you'll have to endure, because hopefully this will be a short presentation. The application reflects my knowledge at this point regarding SPL library, and here are included somehow only basic features, and the program will be developed further once I acquire more knowledge regarding using SPL library. So this is the main screen, and we will create a fake project because we can't have access to the controls and options if we don't create a project. Right now opening and saving, loading a project is not functional, but I'm working on it. In the end I will use XML format, as is handy, but it is a little bit of work, and right now I have a cold. A cold that is lasting a little bit too much. This is the only thing regarding open a project. You have here a preview of existing project files, and trying opening that, it will complain about missing a file. I'm working on this, so we'll close this one and create a fake project. Let's see, it doesn't matter the name. These are also not important for this, but license type, let's do it MIT. The year of the year when the application was created. I want here to have a range, the starting year and year where the copyright is extending. I don't know this stuff too well yet. Here at debug options, I don't have an optimization level OG, because I found that the 0 optimization level is the best using with debug, because you have access to all the variables of your program, and it reflects actually the real logic of your program. So optimization you'll do when you are sure that your program is working correctly. Now, floating point support. If you use for floating point, you have to enable this check box, and if you want to use sprintf function with floating point support, you also have to enable it, otherwise it won't show your floating point numbers. It can be used separate. This can be used separately of this one if you don't show display, but you use floating point calculations in your program. This will be reflected in the make file. Some options will be activated there, and everything included in the compiler parameters. And this is something that is missing actually from CubeMX, at least from the last version I used, but I think they can add it very easily. Actually, there is no problem. Well, if they want to offer that option anymore regarding makefile based projects, considering that they bought the Atomic IDE, but it would be nice to continue to offer that. So we are creating a fake project, and here you have access to clock settings. It's not so actually it's not a real solution regarding clock setup compared with the CubeMX software. You have only basic things. You always run this board at maximum speed, considering that this board has a slower speed than the others, only 32 megahertz, and I don't imagine you will use a 32-bit microcontroller on a slow speed when you can use 8-bit microcontroller. So this will be at maximum speed, and it will be internal clock at 16 megahertz or external clock at 8 megahertz, be it bypass clock source or crystal 8 megahertz source. But when you select external, you also have an option here, and I think it covers all the cases. Actually, this comes from the examples ST Microelectronics offer regarding using Nucleo boards with SPL drivers. So this is based on those examples, and we are thankful for that. What more you have here? It's about SysTick. When I learned LL drivers, low level or layer drivers, I don't remember exactly, SysTick wasn't functional. You had to use HAL to combine HAL with LL to have a SysTick active. So I learned how to use time 6 and 7 timers as a SysTick, and this was originally intended for LL drivers, but as we don't have full control on that, because it's continuously developed, then we have to use SPL as is a major product, and somehow the development sees it on that. So it's a stable system. So this is now redundant, and I don't know, I consider that it does no harm having it here. Now when you set the PA8 pin as a master clock output, if you activate it, this became active, and you can change this and the source. And in the pinout setup window, you will see that the PA8 pin is active now. So this is PA8 pin active and disabled. You can still label it if you want. Disabled. Here are the settings you can do. Avoid using not available option. It's here for the logic, program logic, and right now I didn't find a solution to avoid this, so the user must avoid clicking on not available option. So this can be disabled by going back to clock setup window, or selecting a peripheral that use that pin, and it will override the settings. So these are all the things you can do in the clock setup window. It's a basic thing, but it's addressed to beginners that moved from 8-bit microcontrollers, and this way they don't need to be confronted with the huge complexity of 32 microcontrollers, and this is more like home for them, in at least in my vision. And it's easy to start them in this new family. Then they gradually learn new things if new needs arise. So if you plan to move the world from the 8-bit to 32-bit, you have to offer them a comfortable way to do it. Sorry. This was intended as a tool for teaching, and I think I was misunderstood, and people got mad. Anyway, that's another discussion. The only timers right now that I know to work with are time 6 and time 7. And here the usage is somehow similar to LL drivers, HAL drivers, because as I said, this was intended as a solution for CubeMX. So you can use these two. The other timers are disabled. When I will learn to use them, I will activate this and offer support for these timers. We have I2C peripherals. USB is not yet, but I intend to solve this problem, and you can use it because in the clock window we have the external activated external clock. If it's on internal, as I use it frequently, you can use USB anymore, and the message appears here. Actual clock configuration does not allow USB. When you see that, you must know that you have to go here and change the clock source. On a Nucleo board it's easy because you have both options, but if you have another hardware, it depends on what you use. user 2 is permanently activated. See, you can change this, you can deactivate it because it's used by the programmer on the board to upload programs on your board, and anyway, it's permanently active. Doesn't matter if you don't use it in your program. VPC will make the settings and will insert a call to the init function in your main program. All you have to do is to disable it if you don't use it, and this will decrease the size of your program. Now, another thing that will increase your program size is the inclusion of how to say, the interrupt hierarchy, priorities. I initialize to the priority group 1, but you can select any kind of priority group and the code will be generated. As I understand, I might be wrong, at the starting time the microcontroller is already initialized with priority group 0, and some basic or important interrupts are already on 0 priority, and you can exclude them from your program and your program will still work because they are already set. So you'll see when I'll show the source what it's all about. Anyway, you have to open the project settings window to set your own priorities regarding interrupts. Here you will have a message that will show you the ranges. I don't made strict checking of the ranges at the clicking moment. You can choose values like this, which are wrong regarding priority group 0, but when you press the OK button, a checking function, a global checking function will set the things right regarding the group you selected. Let's see, 15 and 15, which is not valid for group 0. Press OK and let's check again. So it was corrected. I would have liked to have a strict verification at the selecting moment, but it was too much to work, and somehow I was tired, but it remains for the future. Anyways, if you know this, this header file from the SPL driver, and you have there an explanation regarding the hierarchy of the priority of the interrupts and these groups and their dominant. You have here a message regarding range. So if I select group 1, you will see priority range from 0 to 1 and priority range from 0 to 7. Let's choose this one. For every group you are presented with the ranges here, so you don't have to have this header open to see what this means. So this one is permanently active, as are the pins that are already connected to some functions here, a button, a LED, these are permanent. At least the PC 13 pin that is connected to the user button, this is, if you want to use it, then you have to desolder this, but is what the board offers, and if you have another board, you have to redesign this interface, and then you have to activate this pin and offer the full functionality. For the pin LED, there are two possible functions. So is you can select it, and if you select the SPI peripheral, when you do this, the other two pins will be activated, and you have three windows with settings regarding the pins that show up. I will show you. So I'm selecting SPI1, and we have PA6 pin tuning. You can let it like this, or you can change. Again, avoid non-available option. You can let them like this. Now PA7 pin, and now PA6 pin, in this order, and you have activated the SPI1 peripheral. So this is the only option for the PA, only two options from the PA5 pin, working as an output for the user LED or as an SPI. If you select back the LED, it will offer you to select to tune it, and the others will be deactivated, and here SPI1 is deactivated. Let's show it. If you select here a peripheral that is supported by my program, on the frontal panel it will be also activated. It's checked, and you can do the modifications, tuning, and if you use the global interrupt of SPI1, you also have the possibility to set the priorities and sub-priorities. You can disable it from here, and that will be reflected on the pinout window of configuration. If we do that, you see here that it was reverted, and this is true for all the peripherals that are present here. You can activate, deactivate them from the frontal panel or from the pinout configuration setup window. So USART1, before that, these three peripherals are working in UART mode, asynchron, and the simple mode, to say, if I can say that. And I want for USART1 peripheral to have all the functionality that microcontroller can offer. So it's something in work, and it will not be available too soon. Right now I'm working to the saving the project's functionality. Now here are the third-party functionalities, and a part of SD card that I intend to include and support, there is an alphanumeric LCD, and that can be of these types, rows and columns, and two options for the chipset the LCD use. and it can be custom, and that means that you can select any pin from the pinout setup in a random order, but as long as you use these labels, because these are used in the library that I offer for the LCD. And if you don't, when you try to generate the code, the VPC will check if those pins are present if you use the custom option. If not, if you use the default option, 6 pins from the board will be selected and you are not allowed to change them. They will be selected and deactivated to prevent changing them. And I choose these pins regarding Arduino controller, because these are the pins that I use in the Arduino controller, and probably others do the same. It doesn't interfere with the peripherals existing on Arduino board. This is for the default. If you use custom, then this will be reverted to reset state, and you are free to choose any other pin for the LCD peripheral. By the way, the LCD, the microcontroller's peripheral regarding LCD screens with segments, I'm not supporting. It uses tons of pins, and I don't have that any peripheral that it needs this kind of functionality, and I don't imagine a beginner needing that, so currently is not supported. Well, it's kind of very basic what I do, but it helps me in doing my projects and exposing them on a blog, and most importantly, these are somehow persistent, and I mean, and if you 2 years in the future you start to read the blog and try the things, if I'm using my system, you can do it, you can continue to learn. It won't evolve to the point that you are not able to compile it anymore, use it, and so on. So I'm ensuring the availability over time of this system, and it's extremely vital when you make manuals, books based on this. It's very important. Okay, so when you have activated a pin, till then it is in reset state, and this is the pin from the Morpho connector. Let's see this one, set as GPIO input. You have the configuration here set up for the pin, and if you change your mind and want to re-edit the configurations, you have to click on the green pin for the window setup window, tuning window, to appear again. And we also support analog input channels, and this is a recent addition and not yet tested by me. I never worked with ADC on a STM32 microcontroller. It will be a premiere for me. I'm not yet sure if I'm doing this right, but the settings are exactly as in ST examples and as in the library, so it won't give you errors or something. At least it will be a good starting point for you if you try it, and you are more knowledgeable than me. You know what is missing and what to add. So right now it's not tested. You see that here you don't have a check box to activate or deactivate it because it's driven only from pinout setting window, and you have to search for an analog pin, ADC in 0 and so on, all the analog input channels that are available for this microcontroller. You select it. It gives you nothing here, but it tells you that you set the pin as analog input channel, and returning to the main panel, you will see that this green light is activated, and the program will know how that there is code that be generated for the ADC peripheral. And yeah, this is all I can show you right now. Every button here has his own configuration window, and you saw already the pinout. There's not much here supported. I'm supporting only GPIOs as input, output, analog, event out, and GPIO XD. I'm not sure that event out is still is yet supported. I don't think it has complete support. But I generate in the GPIO init function the initialization code for this. You have to check it in the. If you want to see the full functionality, you have to create a testing project and select everything of here and generate. Some things are not yet supported. As I told you before, it illustrates the level of knowledge regarding SPL, my knowledge regarding SPL. It's my these are my first steps in programming an STM32 microcontroller. So you will see that here is a message: this function is not available, choose another. That means I don't have yet support for this kind of functionality. And yeah, this starting from here are supported. When you know that when you set a pin as a GPIO analog, that doesn't mean you have set analog input channel, but this is regarding the noise. You disconnect the pin from the digital channel, to say. And as I understood from the ST community, this also helps in reducing the power consumption. But to me, the noise reduction is more important right now. Anyway, so you can set them all to analog to reduce consumption and noise. The pins that you don't use in your project, but this will add some code to your project and a little bit of size. So you I don't know, you decide what is best for you and your application, and depending on the type of microcontroller you use, what the functionalities present. As I said, if you want an analog input channel, you have to search for the pins that offer that functionality and select it. XT interrupts on ADC, I'm not yet in clear with those. I have to learn how to use them. You can use them in your program. It is not supported yet. Only the input channels of analog. So this is a simplified functionality for beginners, to say. The support will be offered if I'll use and learn STM32 microcontrollers. So this is an unsupported. Any other channel here? Also an analog channel. You can play with it. You can modify the source code to add more functionality. You don't have to wait for me to do it. You can create your own repository if you want to be public, and if it's worth it, you can do whatever you want with the sources. Yeah, that's it. Thank you for enduring the bad quality audio. Bye.